Thanks you, Alex. Alex is so kind. He didn't say that I just called him Matt twice. Sorry, Alex. Thank you guys so much for coming and for all the kind words today. Everyone has been really awesome. I can only, can you see me? I can only attribute it to the city. In New York, when people come up to you and start talking to you, you have to, it's a little scary. Sometimes they're trying to kidnap you, so it's good. It's nice to be in a city where people say hi to each other, not in a scary way. All right, so I'm not gonna, if you saw this morning, I'm not gonna re-go over the same stuff. Wanted to dig a little bit deeper into how we built the hardware behind JewelBots, what our philosophy is around teaching, a little bit about our journey going from software to hardware, which is a crazy thing, and teach a little bit about how that stuff works. So you have the official afternoon talk, it's longer than 15 minutes. A lot of you probably know this stuff if you're parents, but there are a lot of parents that really want their kids learning how to code. And schools are trying desperately to keep up. I talk to parents and teachers all the time. The problem is that software developers make a lot more money than teachers in general. And if you know how to build software and your option is becoming a teacher and making maybe a third of what you would make as a software developer, it's not even really a question. You know, you have a family too. So a lot of schools are struggling to find ways to teach kids how to code. I know in New York City, we are working, I think it's by 2022, they've committed to have every school have a computer science program. That's 5 years from now. That's like forever. And so working hard to get these programs in schools has been great for us. We've had the privilege to work with Girl Scouts and Girls Who Code and teachers and things like that. And so often it's them we're teaching or parents we're teaching that are new coders, which is really neat. So this is a timeline of what, and it's a little bit of a salesy slide, I'm sorry. Bill and I did say we're cool, so I need everyone to know that. JewelBots kind of started with me saying, talking to women and hearing them say, you know, I didn't know what an engineer was until I was in college, and by then it was too late, and I didn't know, you know, people knew what they were doing, I didn't know what I was doing, and I didn't know how to get involved. So I started hacking on Arduino, which is a gateway drug to starting a consumer product, because what ends up happening is you do something with Arduino and you're like, this isn't hard at all, and how hard could it be to make a consumer product? It turns out really hard. It's not the same thing at all. So it was me just hacking on Arduino. I was working at a great company called Flatiron School, which I don't know if you saw today, sold to WeWork, which is I'm pretty happy for them. And I went, and so it was my side project. And then I had a friend named Brady Forrest who had started a hardware accelerator called Highway 1. And basically, the way they work is if you apply to Highway 1, if you get accepted, they give you some seed money for your company. And they have people there that will help you with things like electrical engineering and industrial design, firmware development, which was really neat for us because I didn't know any of those things. However, somehow that didn't scare me. I don't really know why. Did a lot of user research there, and I'll go over that in a little bit. Then we did some Take Your Daughter to Hack Days, which we based on Arduino platforms. We had people come to New York and San Francisco, bring their daughters. We built some neat stuff with Arduino. We're now doing those with JewelBots, which is really fun. And then we did our Kickstarter that I'll go over a little bit. We did an accelerator called Techstars that helped us with the business side of things. We signed a manufacturer, we raised a seed round, shipped our pre-orders. Just talking to someone before about that feeling when when you have a funded Kickstarter, it is both the best and the worst thing in the world because you're so happy, and then you're like, man, I hope I was right about all those things I said. It's really hard, and I really have a lot of empathy for people whose projects are late and all those things. It's really difficult. And then after that, we shipped our pre-orders. We went on Target.com. We went in the Wired store. Microsoft stores gave us out this year. One day, Microsoft emailed us, and it wasn't even Microsoft. It was like their marketing team, and was like, how many do you have? And we were like, I don't know, we have like 800. And they were like, can you just send us all of them? We were like, yeah. And it turns out they gave them out as part of a weekend program. But that's something that you learn. You really can't predict that. So we were 2 months without inventory because Microsoft just bought everything, which is awesome and awful at the same time. At Highway 1, we learned a lot about, I have a clicker here, I'll just use this. Learned a lot about user research. I mentioned this a little bit before. My idea was I was going to make a bracelet. You could wake up in the morning, you could be like, oh, I'm wearing blue today, and I'll turn my bracelet blue. And that'll be really fun. But what we heard from girls is that they really weren't into that. And I'm glad that we asked them. When we got to Highway 1, they told us all kinds of stories about companies that had spent millions of dollars developing a product that no one wanted. And it's not the same as software, because software, you can prototype almost anything in 6 to 8 weeks, right? 6 to 8 weeks, you've got an MVP of something. And that cycle in hardware is 9 to 12 months. So things that take 9 to 12 months, you're spending a lot of money, a lot of resources. So if you don't do it correctly, you're in for a lot of trouble. So what we did is we reached out to schools in the area, and we were like, hey, we'll come teach your kids intro to electronics, intro to programming, if we can ask them some questions. And teachers were stoked. They were like, this is a great opportunity. We got to go meet kids, hear from them, which was really neat. And as I mentioned this morning, the friendship thing just came up over and over and over and over again. We were like, what can we build for you? And when we started saying a friendship bracelet that reacts to your friends, that's when they were like, oh my goodness, that sounds so exciting, which is really great. Oh, I don't know if this guy's working. Okay. So we took all their feedback, we wrote it all down, we met, and we talked about what that would look like. To my chagrin, so we knew it was going to be a bracelet because it would be too big of a ring because of how big the electronics would have to be this crazy ring. And if we got a necklace and it had notifications, you might not see it, right? It's not right in front of you. So we knew it was going to be a bracelet. We sketched probably about 40 or 50 different designs and gave them all out to vote on them. I hate the flower. I hated the flower. I really didn't want to come and say, we're going to teach your daughters to code with this flower. But we sent it to them. The flower, we had pinwheels and stars and all kinds of things. The flower won by a landslide. And so here we are with the flower. But stuff like that has been really neat for us since the beginning, because you think you remember what it's like to be a 12-year-old. You really have no idea. You totally forget. All those times when you were 12, when you were like, when I'm an adult, I will never do this. I will always remember. You don't remember. I found myself standing in front of a lot of classes saying, just so you guys know, I may be an adult, but I'm one of the cool ones. And let me just tell you, they don't believe you. And I'm not actually. So that was a neat process. So after our research and talking to them, we came up with the functionality of JewelBots. We wanted to have an active online community where they can share with each other because they love talking about sharing with each other and learning from each other, and just fellowship and community in general is something that was super important to them. So we knew that this was going to be an important aspect of what we built. The sending secret messages thing was huge. They like to come up with their own languages. I talked to this one developer whose daughter was using cuneiform to communicate with her brother. Cuneiform isn't like really big with them, but coming up with languages that are all their own, it's a big thing. So that was an exciting part for them. And then just the superpowers with code, right? Like, we want to make you a cool thing without the code. You don't have to code it, so people aren't like, oh, I don't want to set this thing up, but make it cooler if you code it. So we worked a lot on different designs and prototypes. And what I learned about building hardware is that you start with two kinds of prototypes. One that's called a looks-like prototype, which is, this is what I want my product to look like in the end. If you look at these pictures, the one with the blue bracelet, that was our original looks-like prototype. So in my dreams, the electronics lived inside there. We had this like little silver button on the top that you can't really see, but it was tiny with this really nice band. And then you have a works-like prototype, which is where you take the electronics and make it work like your product that you want it to look like and work like in the future. And then you proceed to iterate on making those two things closer to each other, and then you have your finished product. You know, this is so with your works-like product, so you can test it, see if it's interesting to people. Our works-like prototype is that big silver one at the bottom. It's like as big as your hand. But we got to take that to people and be like, is this fun? Does this feel fun? Would you like to play with this? So that was a neat process. We experimented a lot with different looks and feels. So that initial bracelet looks really great, and I loved it. We learned two things. When you pull them apart, when you pull the snap apart quickly, it breaks, which was a big thing, and we figured we could fix that until we figured out that little girls' wrists are very different between the girl. Like, between your 5-year-old wrist to a 13-year-old's wrist, it's like night and day. It's like a world of difference. So we had to go with something that was a little more sizable. The first thing we thought of were these guys. Those are hair elastics, right? They wear hair elastics around their wrists already. So we were like, oh, cool, they'll be excited about this. The kids really liked it, but parents were like, that looks really cheap to me, and I wouldn't want to spend money on that. That looks like a cheap product. And so finally, we ended up with a nylon band that I'll talk about in a few minutes. So those were the different things we learned about, you know, when we were iterating on our looks-like prototype. As far as our works-like prototype, that board in the middle is our first board. It has a standard ARM-based RFduino module on it, that square thing. And then, so that's a standard, something you can buy off the shelf. It has Bluetooth and some other things in it as well. It has a button, a motor, and the RGB LEDs. And then we iterated on that. That is a little closer to our board, the round one that's right next to it. The thing that takes up the most space in our device is the battery. We learned that batteries need to be big in order to have a lot of, you know, battery life. And so that's one piece of feedback we get sometimes, is making it smaller. But only from parents so far. Like, kids don't say that. The parents are like, can you make it smaller? So we're working on it. So after we got to this point where we had our works-like prototype, we had our looks-like prototype, we did our Kickstarter. And this was a neat process. Kickstarters are not, especially now, like as things go, it used to be you could like have a phone camera and be like, I want to make a potato salad. And that's like an exaggeration, that was crazy. But it used to be like you could be like, me and my friends want to make a board game, and you could film that and put it on Kickstarter, and it would get funded because people believed in you. But Kickstarters have gotten increasingly harder as people up their budget of how much it takes to launch a Kickstarter, right? Like, you know, people are spending like $30,000 to $60,000 just on their Kickstarter campaign, which is wild. And we put our campaign together for under $10,000, and that included the video and things like that. But it took a lot of work. It was over several months. So there's nothing easy about doing a Kickstarter. It's just a different form of fundraising. My plan for Kickstarter was, I knew our goal was $30,000, and $30,000 would have gotten us a much uglier version of what we have now. But probably that big old prototype, actually, just strap it around your wrist. And so I knew that I had to get $1,000 a day. So I was like, Sarah, you don't get to go to bed until you get $1,000 every day this month. And you can do that. You need to email people. You need to call people. And then we funded in the first day, which was so awesome. That was actually really cool and unexpected. We were really happy with that. And we got several times our funding goal. About halfway through the Kickstarter process, Bill Nye was also running a Kickstarter at the time, and I just got this email in our message box with a video from Bill Nye being like, Joule bots are cool, and I just screamed in the middle of the office. I was like, oh my God, Bill Nye just beat, it's so great. So that was a really cool experience. Kickstarter is a great community. They do get you started with a group of people that really care about your project. We were 4 months late. 5 months late on our project. We communicated as much as possible, which was important. Things that made us late, the laws of physics. So, so it turns out, I'm going to talk to you a little bit about our board, but our microprocessor that we used. But our microprocessor was sold to us by a really awesome salesperson, very good at his job. What that salesperson did not tell us was that the board was not even in alpha when he sold it to us. So when we were in the process of development and we went to order, okay, now we have to make 100 units for testing, we learned that all of our microprocessors, it was totally sold out everywhere because other people were using it for testing and people were buying them up because they really liked them. And there was an 8-week lead time on the board. So that means there's 8 weeks where you're paying engineers and you're not doing anything, and there's nothing you can do about it. And people ask often, everyone says hardware is so expensive. What's so expensive about hardware? Is there going to be a big cost that's like a surprise? No, there's no big cost that's a surprise. It's just time. You just never think, oh, this is actually going to take a year. You're like, this will take 4 months. And then you have a team that you're supporting during that time, and that's how hardware can get so expensive. But in the end, we were able to do it. We shipped last November. It was really awesome to know that they were in the world. We held our breath that day, and we were like, God, we hope all these work. We're pretty sure that they do. We tested them a bunch. Our initial units, it was kind of a bummer, and if you were a Kickstarter backer, I apologize in person. We had to have people update the firmware. So what you learn about firmware, and I'll talk about that a little more as well, is imagine the world of software if open source never happened. And that is the world of firmware. There's no open source in firmware. It's very, very rare you see an open source firmware project. And so the firmware was actually the hardest part of building for us. It took a lot longer because sometimes documentation is just wrong, right? It's just wrong. And you work on the same thing for 3 weeks, and there's no Stack Overflow. I mean, there are sites, there's EE Stack Overflow, but everyone's working on different processors, and the problems people are running into are so different that it's not I'm working with jQuery, and I need to know how to load an image. You know what I mean? That was difficult, so we had to ask people to update their firmware by plugging it in and uploading it with Arduino IDE. So that's some of the pains of early hardware. So if you did that, I really appreciate that. We also offered to, if people wanted to mail it to us, we'd do it. So some people did that, which is nice. So the product that we ended up with were these guys. So the bands and charms are interchangeable, which is fun. We're working on new bands and charms for that as well. And that's been the design from the beginning. We ended up with these nylon bands. They're sizable. We have so many different sizes for so many different wrists, which is great. You can throw them in the washing machine. Important when you have kids. Also, something I learned as part of this process is how many different kinds of plastics there are. There's all kinds of different plastics that you can use with different flexibilities and things like that. So that was a neat part of the process. And then the JoulBots hardware lives in this piece of plastic. the combination of the charm and the hardware housing makes them water resistant. So we had lots of tests where we were just like throwing it in buckets of water to make sure that that was okay. So if you end up doing that, your JoulBots will be fine. So on our board is a button. Each JoulBot has a button, 4 RGB LEDs. The primary colors of light, if you don't know, are red, green, and blue, not red, yellow, and blue like the primary colors. And between those, you can make 2.7 million colors. We have a micro USB port, so that's how you plug them in and you charge them. That's how you upload code. And this is our microprocessor, the NRF51 by Nordic. And the cool thing about the NRF51, super new, and the reason why it's so forward-thinking is because the way Bluetooth works is devices, your devices that you have at home are either central or peripheral devices, meaning they're either receiving messages or sending messages. And most of them can only do one at a time, if not all of them. They can either receive a message or send a message, one of those two things. The NRF51 allows your microprocessor over Bluetooth to have 8 simultaneous central and peripheral relationships. So that means a JoulBot can talk to 3 other JoulBots and your Alexa and your phone and a drone all at the same time. I don't know why you're communicating with the drone. Maybe it's following you. Maybe it's just taking pictures of you as you walk. But that is, those are the capabilities of a JoulBot. So that's been a fun part of the process. And it's really hard for us, actually, to stay focused on the here and now, because we're like, what if Alexa, says, hey, welcome home, Sarah, when you get home, and it, texts your mom, and it's like, hey, I'm home. So I'm just putting those ideas out there in case anyone wants to build them, because we're focusing on the small game. We also built an app that talks to your JoulBot. Right now, the app will connect to your JoulBot and tell you, here are your friends, here's how many friends you have of different friend groups. And we have more features planned for the future. It lets you set up your device easier. We made the instructions easier on your phone. We built it with Cordova Ionic, basically, partially because I love JavaScript and haven't done Objective-C, partially because they have a really good Bluetooth library. So if you're working with Bluetooth, it's better than the native iOS and Android applications. But we're only on iPhone right now. Open source. That's why I'm a pull request welcome. All right, so this is a little bit about how hardware works. And these are all things I've learned over the last 4 years. So if you don't know this stuff, welcome. Just like central and peripheral devices over Bluetooth, your microprocessor, your printed circuit board, sends messages in between your microprocessor and the components on your board. So there's a copper pore, which is the copper that you see, and it sends messages using electricity, using a clock, master in, slave out, and master in, slave out, component to microprocessor, microprocessor to component. And that's how those things work. The documentation for building on stuff looks like this. And as I spoke before, we knew we had to stay with C and couldn't fit a compiler on JoulBot because it's so small. And so how do we make C something that kids are going to be comfortable with, can learn, can write? We had this big chasm between, okay, they can code it versus they want to code it. So all our code uses this function. It's basically how you communicate from a central peripheral on the printed circuit board. And so we had to take that and abstract it out and make it something that's accessible for kids. So we've been working on that for a long time. And now we host events with them, and this is how we teach them. Okay, this is going to be an interactive session. I'm going to put something on the screen, and if you know the answer to what it says, raise your hand. Do not yell it out. Okay, what does this say? I love tacos. So great. What about this one? Fly to the moon, exactly. And what about this one? Great. You guys are really awesome at this. So what does this have to do with anything? So when we teach about what functions are kind of like emoji. And the way that you can use 3 emoji to say I love tacos, or you could use 10 letters. And the reason why we use functions is because we don't want to have to write the same things over and over and over again. So when we find ourselves having to use the same commands again and again and again, instead of doing that, we just write a function. And we name our functions all kinds of things in our events. That's the cool thing about having code that doesn't have to be scalable. You can have a function called unicorn or jewelry or giraffe, and that is super fun when you're a kid. Or an adult, actually. So we have several different things we teach like this. Sure, if they went to work at Oracle tomorrow and said, I know about functions because they're like emoji, people would be like, no, that's not true. But also, your 11-year-old is not going to work at Oracle tomorrow. So it's OK if they understand functions like they are emoji for now. So the different parts of the JoulBot that can be programmed are the LEDs, the button, the buzzer, and using those together, you can make some cool interactions and some cool apps. We call them mods. So LEDs. So if you can see this, you can. Wow, this is a really big screen. That's great. So this is the function that we have in our firmware that writes to LEDs. This is not close to a language that they can understand. So as a second part, we give them, so this is our firmware, and then on top of that, we have like a sandbox that we give them with functions that work for them. So we have things like LED.TurnOnAll, or LED.turn on an individual LED. We give them access to colors like magenta and blue and green in a way that they can just write magenta or blue or green, because they don't want to write a hexadecimal address for a certain type of magenta. They're fine with just the word magenta. This is something that was a big disagreement on the team, and I make sure to point this out every time I talk about it, because I think we're close to a solution. Numbering the LEDs or giving them a position. We ended up giving them southwest, southeast, northwest, northeast, but kids don't really get that, I think. So I think we might change to numbers. Someone had the idea to change it to like an o'clock, like 2 o'clock, 4 o'clock, so we're going to revisit that conversation. So if they want to play with the LEDs, they basically just need to know LED.TurnOnAll or LED.SetLight. And then they get access to functions like this, where they're just turning on a single light, they're turning off all the lights, they're flashing the lights, we have timers, and things like that. So I'm actually going to show you how that works. And I'm going to do it holding a microphone. It's all part of the magic. OK. So in order to code my JoulBot, so this is a JoulBot. In order to code it, I plug it in to a micro USB, like this guy. And I open up the Arduino development environment. OK. So this is a new sketch. So this is where they start. Arduino sketch by default gives you a setup and a loop. Your setup are things that you want to write once into your function, and your loop is where you want code that gets written immediately. So I'm going to type and then explain. I can get this guy. Okay. So in my loop, I'm just going to instantiate the LED class. So they do that by saying LED, LED. And then they can say things like LED dot turn on all. You know, I really thought I put down all my, took away all my notifications. I really hope. Okay, great. Turn on all, and then I put in a color. So I might put magenta. And that's it. So that's a hello world. That's where we start in all our events. Hello world for JoulBot. And so I'm just going to close that. All right, so in order to upload, first I'm closing my messages. I doubt anything scandalous would happen, but you never know. Magenta, thank you. Thank you. It's pair programming. Okay. So in order to code my JoulBot, I first make sure that I have my JoulBot board selected. When they first download the JoulBot IDE, they just need to add the JoulBot's boards, which is like a 3-step process. I have the correct serial port, and then what I do is I hold down the button for 2 seconds, so that's 1 locomotive, 2 locomotive, and my lights flash purple. I then hit upload. It'll prompt me to save it. I'm going to save it. And it uploads onto the device. This takes a few seconds. One anecdote, so everyone has their own way of counting seconds. There are 1000s, there are Mississippi. Some people say millisecond, which doesn't make any sense. It's not correct, actually. Does anyone have a different one? Locomotive. Did I ever say that one? Mississippi. Mississippi's a big one. So what I'm waiting for is for this to do a rainbow color. And once this goes a rainbow color, I know that my JoulBot is coded, and I can take my JoulBot off my micro USB because my firmware is ready. Okay, so that's my rainbow color. And now, if I unplug my JoulBot, I like to put the charm on. I have my magenta lights. So that's my hello world. So there's not, and now you have a flashlight that's magenta, which is like, okay. But if it's your first time ever coding, it's really exciting because you get to see something physically in person that you have done, and you have made this great change in the world. So that's what we always do together in our events for the first thing. And then we walk through a lot of the other modules that they have access to. So for things like animations, we give them access to different animations that we've written. Like animation.rainbows give them a rainbow animation, which they love. We also give an animation called Breathe All, where the lights come on slowly and turn off slowly, and they can pick a color. We give them access to the button press event, so if they write a function for the button press, that allows them to take control of the button press in general and do cool things. So what's the coolest thing we've seen so far is a question that I get a lot that kids build. My favorite things are the friendship interactions, but my beyond favorite thing was beyond favorite. I hang out with 10-year-olds a lot. I have a favorite thing and a beyond favorite thing. My mostest favorite thing is a game that was invented by one of our ambassadors. Her name is Sumi. Sumi's given 2 talks about JoulBots to different development conferences in front of adults, which is a really brave thing to do when you are her age. I believe she's 12. And this is a game called Catch the Leprechaun, or we change the game based on what your favorite color is. So basically, we pick a color, and I'm actually going to upload the game while I'm explaining it to you so that I can show you. So again, I'm going to hold down the button for 2 seconds. Mississippi. Gonna get the purple flashes. And just make sure I have the right port. Okay, so this game, basically what they do, and please excuse the function names, is the JoulBot flashes all different colors, and you pick your favorite color. So Catch the Leprechaun was based on the color green. I always pick blue because it's my favorite color, but you pick your favorite color based on what it is. And when the JoulBot flashes that color, you hit the button. And if you get it right, the colors move faster and faster and faster and faster until you beat the game. If you get it wrong, it restarts from the beginning, which has been a really fun game to build with kids. They get really excited. It's actually really hard to play. They're much better at it than we are as adults because they're faster and they have tiny hands. But the game looks like this. And in this case, so we go through the process of making functions and variables. They learn about if statements, conditional statements, if you can see if monkey equals blue, different fun things like that. And as a result, so when we get it right, when we get it wrong, we'll get it wrong first. It flashes and buzzes, which I felt the buzz. And if we get it right, we get a rainbow and it goes faster. I'm not as good at this game as most of them are. But it's super fun. If you want to play it, let me know. You can come up and play. But yeah, so that's how we make programming accessible to kids. They're great to work with. They're super smart. One thing people ask us all the time is why we don't have a drag and drop interface. Drag and drop interfaces are great. Kids are really smart, and they don't really need that. They are. Drag and drop is wonderful, and it introduces them to beginning coding concepts. We may still build a drag and drop interface, but there's nothing like being in a room with an 8-year-old who's so stoked about C++. It sounds crazy, I know. You might not believe me, but I promise it's happening. So if you work with kids or you're interested in getting started working with kids or anything like that, feel free to reach out to me via email. I'd love to hear what you've learned from them and vice versa. Again, I had that how you can help screen, but if anyone wants to build for JoulBots, we're around on GitHub. So thanks so much for coming today. If you have any questions, feel free to come up and let me know. But thank you, everyone.